all right, I tried with that other cardioid microphone, and yeah, if depending on how my Craigslist ad does, I might end up doing a free giveaway with it. It's just like I know that cardioid microphones have very specific pickup patterns, and if you move your head, where it's pointing is different. But I have a Shure SM35. I'm not kidding. That microphone is like $90. It's a cardioid pickup pattern, and the headband is an uncomfortable piece of shit. But let me tell you, when you move your head from left, right, up, or down, you get the exact same sound because the headband is constantly pointing at the same place. The DPA D-Fine 88, I'm sure it's a great microphone if you stand like this and you don't move at all. But like when you move like this, that the headpiece is so. I hate to say it because I love DPA. Again, this thing over here, this 4065, this is the. I love this DPA 4065. I'm making it a condition that if Eli, the computer guy, visits here like he's supposed to in December, October for that YouTube thing, and he does an interview, I'm gonna make him wear one of these. You don't get to interview me if you're not wearing one of these microphones. That is how much I love this thing. I'm gonna make Eli endorse a DPA 4065 and wear a grape. But my point is, I love their stuff, but the build quality of the D-Fine 88, it's like, what the are you kidding me? Like, if you move from here to here, the mic just goes glub, glub, glub. I finally thought I got into a position where it wasn't moving nonstop, and it does. Now, I figured out how to get it to not move nonstop. I figured out how to make it actually workable. I taped it to my face. I'm not kidding you. I took this Captain tape, and I taped it. Like, I tried with the clip. I tried putting the clip on the wire, putting the wire on the back of the shirt, but then when you move it like this, it's so flimsy that literally the wire moving just makes it move. So I took Captain tape. And I taped it to the side of my face, and that's just, no. I would literally rather give that thing away than have a $500 or $600 microphone here that only works properly if I tape it. But this thing, I mean, it looks like a coat hanger. Don't get it twisted. This looks like a coat hanger, but my God, it is durable. It is strong. It's like, I mean, I really didn't appreciate the sound of it. And I only got that other microphone. When I thought that this thing was dead. I figured I might as well try something new. Oh, never do that. And then this one wound up being fixable. You should see how short the cord is on this thing now. Like, it has to clip to the bottom of my shirt because the cord is so short, it won't make its way to the wireless transmitter if I put it in my pocket. But, man, I love my DPA 4065. I have to find more of these. I just don't want to pay $700 for it, so I wait for them to show up used. Anyway, I've been rambling for 2 minutes and 42 seconds about something that has nothing to do with board repair. So now that we've scared away all the annoying people that are going, Lewis, I didn't subscribe for this, I didn't subscribe for that. Now we can get to some actual board repair. Let's take a look at this. This is a machine that, as always, has had nothing spilled on it. And it's funny, this is the first machine of the day where I was telling myself, first machine where I said, you know what, maybe I'm just not going to wear gloves. Let me just be normal and not wear gloves while I'm fixing something. And then the camera's in black and white. Wow, we got to get you in color so you can see that in all of its glory. Hey, little guy. What are you? Ew. Oh. I don't even know what that is, but ugh. Anyway, so let's get this thing out of the machine, and then we are going to get into figuring out what's wrong with it. It's definitely not water, because they told me it wasn't water, and by God, they would not say that it wasn't water if it was water. So let's open this up. We're going to take the board out, and we're going to see it's going to be something else. It's going to be spontaneous combustion. Maybe I'll find a note in there where the board says, "I'm sorry. Let's just be friends. I can't be your computer anymore." Maybe it decided to stop working on its own. We'll see. Let's see what we get. What do you guys think we're going to see? What do you think we're going to see on the bottom of this? Holy moly. There's a chance that there's no water here. Unless I'm blind. Alright, let's go through this. My God, this may be some... Oh, you telling me I had an honest customer? Whoa. Whoa. Stop the presses, baby. All right, let's take a look under the microscope. This is good. This is amazing. I was not expecting this one bit. All right, let's go over and see. So we got a little bit of pubes, but not more pubes than expected. This is actually a very conservative number of pubes. Got nothing bad to say about the number that I see here. Let's get this a little bit more in focus for you all. Okay, we're gonna just go up and down, up and down, up and down. Remember, we always like to look for the obvious hints. Oh. So close. So close, man. Alright, so we got something. See how everything's sticking in this area over here? Yeah, that's some sticky shit. That is liquid. Alright. Oh, in case any solder joints have broken off. That's a really small amount of liquid, I gotta say. You know what? I'm not even gonna say anything mean here. I'm not even gonna say anything mean. Because that's a really small amount of water. Like, I don't think even I would notice that amount of water. I don't think even I would notice that amount of water. So, let's get right into this. A little bit of hot air and a little bit of flux. Are any of the joints over here off? Okay, now keep in mind that is the SPI ROM chip, so... So we know it got in around the edge. This is irrelevant because it's not near any contact points. Anything interesting? Yeah, it looks pretty boring to me. Pretty boring. I'm not seeing anything of note here. Alright, so we might as well just start going through power rails. And go from there. So, let's get the microscope camera out of view, and we're just going to go over some of the power rails. I'm loving this microphone. I don't have to care about it every time I move my head if it moved up or down or anything like that. That was such a pain in the ass. You have no idea. I'm most likely going to wind up giving that away for free. Alright, so let's go through the list of rails. This is my multimeter, which is always just out of view. Great filming. So the first rail that we want to get is PP bus G3 hot. Should be 12.6. Says 12.8 in the schematic. It's always 12.56 in real life. And 12.53, close enough. Next up on the list is going to be PP bus S5 HS other computing, which is always there unless there's a resistor that's destroyed, which would have showed up, so I ignore that. PP DCN, well, if I have the first one, then the charger's working with common sense, so we ignore that. PP3V42, that's showing up because I have a light in the charger, so we ignore that. PPV RTC G3 hot, let's check that one out. And I'm going to go through the list and find the rail that's missing. In the schematic, there's going to be a list of power rails, and what? Seriously, idiot? How did you miss this? Dum-dum? How the fuck did I miss this? How many did... I'm not sure. Did I not go over this part of the board? Or did I go over this part of the board and actually not see it? Because if I actually went over this part of the board... Like, look, not... Did somebody just swap the board in front of me on the desk? Like, was there a gremlin here? Are you fucking kidding me? Look at this. It's still... Not only does it still have liquid on top of the chip, but this is, like, red and covered in green pubes and red and... Ugh. How the... I'm genuinely curious. Did I miss that? Did I miss that? Did I not go over it in the camera, or did I actually go over it in the camera and not see it? Either way, that's unfucking excusable. That's unexcusable idiocy right there. But that is what you guys have probably come to expect from this channel by now. So we're going to go over that area. Now this is the clock chip. This thing's responsibility is to create sysclock, the 32 kilohertz RTC signal that goes to the PCH, platform controller hub. A platform controller hub is kind of like a combination between a north bridge and a south bridge. And on here, it's integrated into the CPU. So that is creating the clock signal for the CPU. Now, the CPU is going to put out a lot of different signals in this machine that say, turn on this power rail. So for example, PP5V S4 in this computer, the CPU is going to tell it, turn on the 5-volt rail for when you're in an S4 state. Now, it's not going to do that if the clock isn't on. Without the clock, it's not going to initialize any of that. And, oh, look at this. Look at this. So I'm going to take the assumption, the cap is obvious. I don't even care if it's the cap that's bad, but the chip is good, or the chip is bad, but the cap is good. They both got to go. I mean, look at them. Look at them. Disgusting. Ugh. Puh. Yuck. Gross. This is bad wicking. Don't do the wicking the way I just did. Never, you don't remove the wick. You don't remove the iron while the wick is still on the board. That's a big no-no. I'm also using the wrong tip for this, but I know what I'm doing, which is why I'm allowed to do things that make it look like I don't know what I'm doing. That's just me not wanting to buy another bevel tip since the other one got destroyed by us. Alright, so now it's time to solder on a replacement chip, which is just going to be... So what I'm going to do here is I'm just going to tin each one of those pads. We're going to have an... It's going to look like a nice little landscape. Nice little landscape. Little valleys and peaks and valleys and peaks. So build your landscape. You're just going to put a little bit of flux. This, and now see, 1 pad, 2 pad, see, See, this is what I like about this tip. You get the elbow for when you want to do wicking and heavy stuff like this. Then when I want to do one at a time, I can use this really fine point. That's the T15 JS02 tip. I love it. I love it so much that I'm putting up with HAKKO's warranty procedures on the iron that I have that doesn't work. Some people think I'm paid by these companies to say what I like. I'm really not. No company in their right mind would ever sponsor me for any of these types of things. Because I say what I think about the product. Sometimes what I think is not something that's going to make the product sound like something that they're going to sell. Now, I also have this strange feeling that PPVRTC, the via going into the board, may be half connected. So I'm actually going, after I put the capacitor down there, I'm going to run a line from there to somewhere else on the board where PPVRTC is present, just to make sure that there's no funny business and that it doesn't disconnect. It really does look bad. And we're just going to get some solder on that center pad. And as usual, I got too much solder on the center pad, but you'll see how we fix that in a moment. So... we may notice that when I'm zoomed in more, that it goes in and out of focus a lot easier. That's why I usually do all my work at 7x, because I don't need a lot of zoom, but I do want to not get dizzy. I mean, it's cool when you're buying these to see, I can pay $100 more to get the one that has more zoom. But is it cool when it's constantly going out of focus and driving you nuts? I would argue not so much. Anyway, let's just... Okay, now let's grab a capacitor. Let's go shopping for a capacitor. I think I got one. I like this coat hanger microphone, I really do. It's the fact that it looks like a coat hanger is I like it even more, because people think it's cheap. And people are like, oh my god, that's so silly, why do you use that? And then you like, show me another tech video where somebody has, like, show me this. Show me another tech video where they have a 35,000 BTU air conditioner, a hot air station with a powerful pump, a fume extractor with the hot air station with the powerful pump, where you can hear exactly what they're saying. It doesn't exist. It doesn't fucking exist. Good luck. Unless they like did the audio over after they were done with it. Alright, so a few things I want to touch up here. I believe I accidentally wicked this resistor that's down here. I wicked that. And the second thing, as I said again, I don't trust that connection there. So I am going to attach a wire from there to another point on the board where PPVRTC_G3hot is present. So first things first here, let's just get tipping. There we go. Make sure that's nice and connected. I almost kind of want to I don't know if that's making a great connection to the capacitor. Scrape the solder mask off. And just solder directly to the board there. There we go. Nice connection directly to the board. Now I'm going to wire that to somewhere else that PPV RTC _G3 hot is present. And this is where the board view may come in just a little bit handy. So if I do this, where else do you show up? Well, you show up all the way over there. You show up on this connector on pin 40. That's hard to find. So I'll wire you down here to one of these 3 caps. Yeah, that's reasonable. I can do that. I'll do that. So now all I need is a little bit of fine wire. Again, I may not need to do that. This is just one of those things that I was talking about in a few videos ago on, you know, you don't really want people to come back with the exact same problem they had before. And one of the ways you keep that from happening is by touching up all these little things and anticipating what's going to go wrong before it actually goes wrong. And I want to anticipate what goes wrong before it goes wrong. Speaking of anticipating things going wrong, the short wire on this microphone, I must say, is starting to drive me nuts. I'm trying to clip the thing to a belt loop because I can't, it won't make it to my pocket. And the little belt, the clippy thing came off. So, here we go. We're all clipped on. So now what I can do is I can go over to that area with those three vertical capacitors. Let's just find that section of the motherboard. Looks like this, all right, so I can just attach wire from there. There we go. And hopefully from there it attaches to the CPU and everywhere else on the board. That's my hope, is that if my path is broken, that I can recreate it like this. So let's say my path, you know, let's say it goes to the CPU and then it goes here. If I attach through here, so let's say this goes to the CPU and that path is broken, and then from the CPU it goes. I guess actually, yeah, that would still work. Anyway, we'll see. Well, let's not chicane the idea before we go for it. All right, so let's attach to here. Let's get my little wire. Keep in mind, you don't need huge wire for this. Again, if I was attaching, let's say, wires for the DC in rail, that's going to be powering the entire computer plus powering the charger. Yeah, I'd have to think about using a really thick wire. Here I'm using a thin one because we're dealing with small components, so it's going to be easier to work with. But the primary thing here is that it's also for, you know, it's a 3-volt line that's not going to have a lot of power going through it, so I don't really particularly need to care. Okay, soldered. Now let's take a journey to the other side of the motherboard. And damn, these tweezers suck. These tweezers are a joke. Why don't I gotta get some new set. All right. See, these tweezers are an equal, if not bigger, joke. All right. Okay, scrape, scrape, scrape. Now, it's not great. I just wanted to scrape over the insulation off the wire so that I could properly solder to it. Now I can actually do the job of making a nice joint there. So I added some flux. I scraped away the board And yeah, it's good. Okay, so now I can break off this wire. Beautiful. Beautiful, beautiful, beautiful. Okay, now we can plug it in and see if it blows up. Blows up, I'm fired. All right, so take the MagSafe, plug you in, and oh, lame. Still dead. Oh, is it at least creating PPV RTC G3 hot? It would suck if the CPU actually got killed because it sent a spike to it. That's the thing with these CPUs. They're complete pussies. All the Haswell series CPUs. Haswell is a big pussy. Same with Broadwell. Those early Core 2 Duos, they could take spikes of 12 volts and be fine. Yeah, so it is there. Sigh. All right. Well, let's just continue down the power rails anyway. This may wind up getting fixed by the ultrasonic. There could be something hiding under the CPU. But I have a feeling that... First, let's just go over what creates PPV RTC G3 hot. Let's go over this for a minute. So... all right, so PPV RTC is used to pull up some of these signals, like intruder, intervermin, SRTC reset, RTC reset. So you should always check over there to make sure these are being pulled up. Sometimes these capacitors can be dead and shorting it to ground. Sometimes the resistors can be screwed up. So PPV RTC is used for that. It also pulls up this DSW VRMN signal. And this over here, this creates PPV RTC G3 hot, as well as the clock for some other areas. Now the thing is, this is powered off of PP3V42 underscore G3 hot and PP3V3S5. So let's say there was water and there was ripple. Let's say, you know, on the PP3V42 rail, there was a spike of 12 volts or a spike of 16 volts, and 12 or 16 volts are what create PP3V42. So let's say PP3V42 for a minute just decided to go to 16 volts. So the circuit that creates PP3V42 is going to be, yeah, I'll show you how this works. Come on. Yeah, this, so 3.42 volt supply. So 3.42 volts is on output, and on input you have, you follow back, the direct DC in charger line, which is 18 volts. So if there's a quick bit of if there's a quick spike on that, not only is it going to kill this chip, it's also going to kill the PCH which is attached to it, because PPV RTC G3 hot is going to go up. And this goes directly to the CPU and PCH on this board. So this chip is powered by 3.42 volts, and it creates 3.3. If this chip powered by 3.42 creates 3.3, what if this chip for a quick moment is powered by 16 volts? Then PPV RTC is, and you see where that just kind of screws everything up. So, oh, that would suck. Come on, be fixable. Be fixable. All right. Well, let's just go through the power rails and see what's missing and see if we're completely screwed. So the next one is PP5VS5. So we're going to check PP5VS5. And... kind of like the other microphone better now. When I had the other microphone, the boards I fixed actually worked. All right, so PP5VS5 is 5.14 volts, which is good. Okay, next rail on the list is PP5VS4. And that's the one that's probably going to be missing, like always. So we check for PP5VS4. And PP5VS4 is, whoa, PP5VS4 is 5 volts. Interesting. And it's on. Oh, it is actually on. The fan came unplugged. Whoa. Oh, man. Well. You fucking idiot. No, other way. Do this. Idiot. Anyway. Fixed. That's pretty cool. I'm liking this mic again. This mic is my good luck mic. Fits my character. Yeah, that's my wire. You're not going to see that because the camera is set to focus on my face, but I can always turn that off so you can see what it looks like in context. So let's turn on auto and then turn off face focus and... Beautiful, isn't it? Absolutely beautiful. This is a pretty motherboard. I know. It is a beautiful motherboard. Let's see how much And that's it for today. And as always, I hope you learned something.